Alright guys, welcome to my second video. We will continue the same topic, basically the final project. Okay, so we stopped at the Boolean equation and final circuit in the last video. You guys can check it out and continue to watch the second video. Okay, so basically in this video I will show to you guys on how we compare between Boolean equation and on how to create the final circuit and run the simulation. So okay, let's get started. We start with the T5. So T5 is basically the input of the fifth flip-flop, which is the top one here. So basically we just look at the Boolean equation. Boolean equation, we know in this Boolean equation we OR, okay, the plus here is the main before we connect it to the input of T5. So basically we OR between two AND gate. So first AND is only with two input, and the second AND gate is with the with 4 input. So let's take a look. Okay, for this one, for the first AND gate, okay, is the not Q4 and Q5. So basically what is not Q5 and Q5? So basically Q5, okay, this is 5, 4, 3, 2, 1. So the top one is Q, and the down below here on every flip-flop is the not of Q. So this one is Q5 and this one is not Q5. So for the first AND, we AND the not Q4 and Q5. So basically this one is Q5. So Q5 connect with the AND of not Q4. So this is not Q4, not Q4, not Q4, not Q4. So basically this is AND of Q5 and not Q4. So same goes to every single AND gate here, and for every flip-flop there are OR gate, okay, connected to the input. So this one is OR gate for T5, this one is OR gate for T4, so OR gate of T3, OR gate for T2, and OR gate for T1. So that's it. That's the counter. And the triangle there, the small triangle there, okay, if you guys can see it, is basically the connection with the clock. So this one is clock, and I just connect the reset. Okay, if anything happen, I just set it to the 1, so it will reset the whole counter. So let's move to the simulation. Okay, I hope you guys understand on how we get from the question we derive in the state diagram. Basically state diagram is all about the sequence of the counting of the counter, and from the state diagram we express it in binary number, and binary number we put in the state transition table, present state, next state, and the excitation table is basically compared with the characteristic table of what flip-flop that we use in the project. And then for every single excitation result, T5, T4, T3, T2, T1, we express the Boolean equation from the K map, because this is the easiest way. Okay, K map and Boolean equation. So for every output T1, here's T1. You guys can pause the video and try and error for every single K map and check whether we get the same Boolean equation. So this is 41, this is 42, this is 43, this is 44, and this is 45. That's it. And we compare the Boolean equation and derive to get the final circuit. Alright, let's go to the simulation. Okay, let's take a look. Okay, so basically, okay, we start. Okay, my ID number is 0107369. Okay, so this is the reset button. I just put it into 1, and then if I change it back to the 0, it will the 7 segment display here will count 0 and then 1 and then 0 back, and then 7 and then 3 and then 6 and then 9. And after the number of 9, it will just repeat the same sequence basically and back to 0, 1, 0. Alright, so you guys ready? So if you guys ready, I will set it the reset button to 0, and yeah, that's it. So the whole counter here will count from 0, 1, 0, 7, 3, 6, 9, and back to the 0, 1, 0. So because of we connect it to the clock, and it will just goes and repeat the same sequence uh, infinite. Okay, infinitely. Okay, I think that's all. I hope you guys can understand and understand clearly and know on how to design a synchronous counter that counts on the sequence that you want, sequence of number that you want. Okay, so that's it, I think. Thank you guys for watching my videos. Have a good day. Thank you.